Welcome back. In this video, we'll be solving example 1.3.3. We just defined what a linear combination and a span was for a general vector space, and we're going to apply that definition to the case of 2 by 2 matrices. I'm going to take S to be the set of containing these three matrices, and I'm going to try to write B, the matrix minus 2, 6, 6, minus 1, as a linear combination of A1, A2, A3. All right, so if I look at the definition, I'm trying to write B as A1, A1, A2, A2, plus A3, A3 for some A1, A2, A3 in R. All right, so that means minus 2, 6, 6, minus 1 should be equal to A1, 2, 0, 3, 1 plus A2, 4, 2, 0, 2 plus A3, 6, 0, 0, 3. I'm going to get, let's spell it out, 2A1 plus 4A2 plus 6A3. So I need 2A1 plus 4A2 plus 6A3. That needs to be my first entry, so it needs to be equal to minus 2. Next one would just be 2A1. So 2A2, sorry. 2A2, so 2A2 should be 6. Next one is 3A1. So 3A1 should be 6 as well. And finally, I have A1 plus 2A2 plus 3A3. And so that should equal to minus 1. All right, so you could put it in a matrix, or really in this case, these two equations give you A2 and A3, and then you can get A1 from any A1 and A2, and then you could get A3 from any of the other one, but you get A1 equals 2 from the third equation. You get that A2 equals 3 from the second one, and if you plug it into any of the first or the last, you get that A3 is equal to minus 3. And so B is equal to 2A1 plus 3A2 minus 3A3. And so that writes B as a linear combination of the three matrices that were given. All right. We want to do that again, but now we want to do it for an abstract matrix ABCD. So give conditions on ABCD that ensures that the matrix ABCD is in the span, so it can be written as a linear combination of the three matrices of S. All right, so we want to have values A1, A2, A3, so that B, A, B, C, D, the matrix that we're trying to write is A1 times, my first matrix was 2, 0, 3, 1, A2 times 4, 2, 0, 2, plus A3 times 6, 0, 0, 3. All right, so you do the same thing that we did above. You put it all in one matrix, and we get a similar linear system. So we would like, let me just write it here. What is it? 2A1 plus 4A2 plus 6A3 equals A. We have 0A1 plus 2A2 plus 0A3. That's the second entry, so it's B. 3A1 plus 0A2 plus 0A3 equals C. And finally, A1 plus 2A2 plus 3A3 equals D. All right, so that's the linear system. We want it to be consistent. So this, we want to have values A1 and 2, so we want to have a solution. So this system needs to be consistent. All right, so we'll put it in. We'll put it in a matrix. Again, it's not so bad because I have two nice rows, but let me, actually, we only need to go to REF. But in this case, because two rows are so nice, it's going to be the same thing. So I'm going to get 300C, 020B, 0, I ended up with 9, I ended up with 3D minus C minus 3B, and finally I get 000. I had a mess here, but when I simplified, it simplified nicely to 3A minus 6D, like that. All right, so I need this to be consistent. The only issue is with the bottom row because I do have my 3 leading entries, and so we need that final constant to be 0. All right, and so we need 3A minus 6D to be 0. Or you could simplify, divide by 3, and get that A minus 2D equals 0. And so if I have to write the span of A1, A2, A3, I could express it at the set of matrices A, B, C, D, so that A minus 2D is 0. All right, so that's it for this video. In the next video, we'll be linking spans and subspaces. The goal is really to show you that any subspace can be written as a span and any span can be written as a subspace.